Let's get right into it. Imagine pouring millions of dollars into saving a lush, vibrant green forest, only to find out later that it's actually biologically dead on the inside. Well, welcome to this explainer where we are diving into exactly that problem and the brilliant solution, the Global Genomic Calibration Index. It was developed by Dr. Saheed Opeyemi Adebisi. He's a sustainability biotechnologist who basically operates at the intersection of, well, everything: the biodiversity climate nexus, AI diagnostics, nutraceuticals, and science policy translation. And he's built this framework using advanced biotech to save our ecosystems from this totally hidden threat. So let's explore how this is literally rewriting the rules of planetary health.
Here's our roadmap for today. We're going to hit 5 key areas. First up, the mystery hook. Second, the abundance paradox. Then, the 3-phase tech pipeline. Fourth, fixing cognitive bias. And finally, the smarter 2040 system. Let's jump in.
Section 1. The mystery hook. So we start our journey by looking at the surface of what seems like a perfectly healthy ecosystem, right? Picture this. You're walking through a dense tropical forest. The canopy is thick, it's incredibly green, it's just teeming with trees. Now, modern global conservation relies heavily on exactly this: observational checklists and surface-level counting. Basically, if it looks green, we just kind of assume it's stable. But here is the core mystery we need to unpack today. Why do these visually thriving forests suddenly collapse into localized extinction? I mean, what if our eyes are actually deceiving us?
Section 2. The abundance paradox.
To answer that mystery, we actually have to expose a pretty massive flaw in how we currently measure environmental health. It's known as the abundance paradox. This is a statistically proven cognitive bias. We're talking a p-value of less than 0.05 here, where a really dense visual canopy tricks observers into assuming an ecosystem is healthy. But beneath all that lush greenery, the population is actually suffering from severe genomic erosion. It's essentially an optical illusion of safety, and it completely tricks policymakers right up until a catastrophic extinction event happens. Crazy, right?
So this really reveals a fatal gap in traditional conservation efforts. We are basically comparing deceptive visual head counts against the terrifying reality of hidden genetic erosion. Think of it like a hollow chocolate bunny. It looks totally substantial on the outside, but you give it one tap and it just crumbles. If we rely solely on what we can see, we end up pouring billions in taxpayer and donor funds to protect sterile monocultures, forests that look great but absolutely lack the genetic diversity to survive even a single new disease. We are essentially funding a greenwashed illusion. We desperately need a way to measure true genetic viability.
Section 3. The 3-phase tech pipeline.
So how does Dr. Adebisi's Global Genomic Calibration Index, or GGCI for short, actually solve this crisis computationally? Well, it shifts us away from just counting trees by using this really elegant 3-phase tech pipeline. We move from automated molecular ingestion over to complex data translation and then finally to empirical visualization testing. Think of it as an end-to-end bridge that turns petabytes of raw, confusing biological big data into immediate, actionable human perception.
Phase 1 acts kind of like a highly targeted digital harvester. So instead of downloading massive bloated files to local servers, it uses lightweight Python scripts running right in Google Colab to securely query the NCBI database, which, if you don't know, is essentially the world's largest public library for genetics. By using specific eutils APIs like eSearch and eFetch, it surgically extracts only the exact plant gene sequences it needs, things like MAT-K and RBCL. It entirely automates the gathering process, which obviously saves countless hours of manual work. Then, in Phase 2, the pipeline cleans up all that messy taxonomic noise to calculate 2 absolutely critical metrics: nucleotide diversity, which we call pi, and effective population size, or NE. Think of these as the absolute, unfiltered truth of a population's genetic gene pool depth. The system calculates these metrics and packages them into standardized data payloads. It even leverages advanced Gemini LLMs to generate plain language summaries. So literally anyone can understand the true health scale of the forest without needing a PhD in genetics.
Section 4. Fixing cognitive bias.
But you know, having all this raw genetic data is completely useless if human policymakers can't intuitively understand it. The old status quo relied on these chaotic scatter plots that just caused cognitive overload and policy paralysis. It forced managers to default back to, just looking at green trees. Well, Dr. Adebisi fixed this by feeding the data into a human-centered design called the Genomic Vulnerability Risk Cone. It instantly breaks that optical illusion by visually flagging a species in a critical risk zone, even if its visual abundance is incredibly high. It completely translates complex data for rapid, data-driven funding decisions.
Now, to prove this new dashboard actually works, the GGCI launches empirical web-based trials using the Revisit framework. This is a scientific tool specifically designed to test human-computer interaction. They run randomized trials simulating high-stakes environmental management to measure precise quantitative human factor metrics. They track decision accuracy, to ensure users actually break that visual greenwashing bias, as well as interaction latency to assess cognitive load and processing fluency. They even measure trust calibration to prevent overconfidence when users are viewing deceptive graphics. It guarantees the dashboard actively prevents catastrophic funding errors.
Section 5. SMARTER 2040 System.
Okay, now we scale this validated technology all the way up to a macro level to enforce actual global conservation tracking. These cognitively optimized metrics are integrated directly into the Smarter 2040 operating system. This equips local forestry departments with the exact tools they need to distinguish between sterile monocultures and true biodiverse reserves. An on-the-ground agency can pull up a dashboard and instantly know, with mathematical certainty, if the forest they are managing is genuinely resilient or genetically fragile.
The ultimate impact of this system is absolutely massive. It functions as the open-access diagnostic tool required to enforce the UNCBD Kunming-Montreal monitoring mandates. That's a historic global agreement to protect biodiversity. For years, international tracking has struggled because it relied so heavily on observational reporting. But this technical solution finally provides the hard molecular proof of ecosystem resilience required to monitor digital sequence information, and it holds international bodies fairly and accurately accountable.
I want to leave you with a really provocative thought from Dr. Adebisi's manifesto. Are the forests we are funding today truly resilient, or are we just blindly paying for greenwashed extinction? The Global Genomic Calibration Index proves that by bridging biological big data with human-centered AI design, we can finally see the forest for far more than just its trees. Thank you for diving into this explainer with me. The next time you look out at a lush green landscape, I hope you'll question exactly what's beneath the surface.